guys might have to turn around so that they can see it. Okay, so far? So Jenna is x2. Can you guys put those things together? Yeah, the ends. And then x3. So you have to touch them. And can you guys all turn around? So that they can see. So that they can see. The whole point is that they have to see. All right. So we're starting off with 3 vectors, right? Okay. So it looks like x1 is just going to be v1, or v1 is just going to be x1.
Change the order.
All right. So I need another volunteer.
Number 2. No, number 3.
I need another volunteer. Can I get another volunteer? Well, I have x1 and x2 and x3, right? What else is included here? These equations. What else is included in the equations? V1, V2, and V3, right? What's V1? V1 is done. V1 is just x1. So V1 is Malcolm. He's x1 and V1. All right? Tito is going to come up now, and he's going to be V2. Can you guys tell him what to do? Or tell him where he should be with respect to those vectors. So let's first take a look at the equation up on the screen. Let's take a look at this. x2 dotted with v1 divided by v1 dotted with v1 times v1. Can you tell me what that is first? Say it again. Projection of v.
Projection of x2 onto v1.
Okay. So just this highlighted portion is a projection of x2 onto v1. Who's x2? Jenna is x2. Who's v1? So I said Tito was going to be v2. So maybe I need another volunteer to be this. Who wants to be volunteer? Who wants to volunteer to be this? Okay. So say it again. Projection of x2. X2, raise your hand. Who's x2? And v1. So what is the projection of x2 onto v1?
It's going to be No, on the same on the V1. I think it's on x2, yeah. Same direction.
Okay, let's take you on here for a minute. Where is she gonna go?
On V1.
On what?
On V1.
On V1. You have to go on V1.
So should it be
So you have to.
I got, yeah, I got. Glasses, you got protection.
Okay? So does that make sense so far? So what we're saying here is that you have Jenna's vector dropping down perpendicularly onto Malcolm's vector, and then you have Miss Fontaine's vector. That's this, just this. Now, theta is supposed to be V2. X2 minus this, what is that going to be? All right, so can you get yourself in there? So, is that okay?
So,
What are you suggesting? Tito, do you understand what you're saying? It's a small difference, but that's what that is, yeah.
So the x2 minus the big equation highlighted, that's your z vector, right?
yeah.
That's your z vector for what we're doing.
v2.
Yeah.
Okay.
So Tito is V2. Okay? Are we good so far? Now, a vector is a vector that just has a direction and magnitude, right? So as long as Tito doesn't change his magnitude, and as long as he doesn't change his direction, then he would still be that vector. Okay?
That's a good question.
So,
Yeah, because then the z vector is y minus y.
is that okay?
So technically, C is going to be the distance between your B1 and your X2 half
Yes.
with B1.
Yeah. So this would be, it's not the distance though, it's the actual vector.
The
So
vector distance?
No, the distance is the scalar. The distance would be the length of the vector.
Oh, okay.
It's the actual vector. All right. So, you bored yet?
So then
So I'm going to move Tito to the origin. Is that okay? You have to go behind them.
I'm sorry, you have direction.
All right. Now, let's talk about... Let's take you out for a minute. I'm going to move you out. Oh, you're holding all that?
Yeah.
No.
He's kind of like, man.
I kind of left him there.
So, I want to talk about x1 and x2. Who are x1 and x2? x1 and x2. And I want to talk about v1 and v2. Who are v1 and v2? So you're v1 and v2. Do you guys see who x1 and x2 are in v1 and v2?
No, can we do that one more time? So
Oh, who are
who's
x1 and x2? They're the original vectors. Who are v1 and v2?
Oh,
Because x1 is the same as v1,
gotcha.
and then we just created a new vector.
Okay.
And Tito is perpendicular to Malcolm.
Okay.
Okay. Now, what can you say about the span of x1 and x2 and the span of v1 and v2?
They're the same.
They're the same plane, right? Who wants to be a plane? I need another volunteer to be a plane. Here. This is flimsy. You have to hold it. Like,
how
so,
do you?
I don't know.
Okay.
You have to go behind them.
Jesus. Wash the eyes.
So, x1 and x2 should be on the same plane. Is v2 also on the same plane?
Yes, it's in a span.
So v2 is also on the same. So we created from x1 and x2, we created a v2 that's on the same plane as those two. And v1 also, yeah. So they're all on the same plane, right? X3 may not be on the same plane. In this case, it's not on the same plane. Okay? But focusing on X1 and X2 and V1 and V2, we understand that they're all on the same plane, right?
Right.
Okay.
I
Yes?
have a question. How did you conclude that X3 wasn't on the same plane though?
Because the problem was like that.
Oh, okay.
How you started?
Okay.
Okay, so now let's move on to this one right here. What is this thing highlighted? X3 dotted with V1
X3
divided by V1 dotted with V1 times V1.
X3 projection onto V1.
So projection of X3 onto V1. Where's X3? X3.
Oh,
Where's V1?
right there.
So it'll be projection onto this, right? Now, what is X3 dotted with V2?
X3 yeah, projecting V2 in a direction of V2.
Which one's V2?
That one. Oh,
So theta is V2. So projection of here onto here, right? I need another volunteer. I want to know what, you have a number times V1 minus another number times V2. Where is that going to be?
Is that your is that your Z vector?
This is not yet, this is like your y hat vector.
Okay. So your y hat.
What?
combination.
It's going to be projection on the plane, right? So can somebody project on the plane? Somebody please project on the plane?
Come on, guys.
I got all kinds of vectors. It has to be on the plane.
On the white.
Is it on the same?
Doesn't have to be, and it
On
probably.
the white.
On the actual plane though, right?
So if I were to try to go down perpendicularly onto the plane here, this is about as perpendicular as I can get, so it has to be there, right? So that's the highlighted piece right now. So I need one more, I probably need a couple more. I need another volunteer because I want to know where V3 is. Can I get another volunteer? So V3 is going to be X3. Who's X3? minus that vector on the plane. Do it with these two vectors first. This one and this one. You're subtracting it. So okay, Thomas moved already to the origin. Go back to the before moving to the origin. Okay, so V3 minus this vector that's on the plane is going to be, I'm sorry, X3 minus this vector on the plane is going to be V3. Okay? So now, he moves it to the origin, and let's take a look at what we have. Let's get rid of the plane. Plane go away. Let's get rid of these two vectors, the projection vectors. Get rid of. And then let's get rid of X2. And let's get rid of X3. what do we have?
Oh.
We have a set of perpendicular vectors,
Yeah.
right? We just created an orthogonal set of vectors. What? Those are V1, V2, and V3. And now we have a set of orthogonal vectors. Okay? So, hold on.
Oh, wait, I have questions.
Now, aside from being orthogonal, we might also want them to be orthonormal.
Okay, here it is.
What is the difference between orthogonal and orthonormal?
Unit vectors.
Unit length. So, can you guys go to unit length?
Uh-oh.
Yeah, there, unit length. Just shrink it all the way down. So if you take these V1, V2, and V3 that you all got, and then divide by its magnitude, each one, then now you have an orthonormal set. Okay? Does that make sense? All right, thanks. Thank you.